Let's start a new topic today. Laws of motion.
Okay.
Yeah. Right. So for a body to move, an external force is required, and the force may be maybe a contact force or a non-contact force. So what is an example of a contact force and non-contact force?
Frictional force and gravitational force.
What about force which is not in contact?
Gravitational force.
Okay. And then
Electrostatic.
Yeah, for that the two bodies need not touch each other. The force will be felt even when the bodies are not in contact. Okay, and if you consider body system, input is force and output is motion. So if you apply force to a body, it will move. So is a force required to keep a body in uniform motion? Yes or no?
No, sir.
Okay, so suppose you apply a force, what will happen to the body?
It will keep going if there is no resistance.
No, whenever force is there, acceleration will be there. Okay, so force is F equal to m into acceleration, right?
Yes, sir.
So whenever force is there, acceleration is there. Okay, so for the thing to move in uniform motion or to be in rest, acceleration is 0. So force is not required. So how do you prove this one? That without a force, the thing will move. So suppose you have two inclined planes like this. If you release a ball from a height h, okay. So what is the height to which say the planes are identical? They're not. And what is the height to which the ball will raise the second plane? Will it be same or different?
Sorry, what, sir?
The ball is released from this plane. It comes down and then it climbs up this one. So what is the height that will be reached by the ball in this plane? Will it be same height or different height?
Different.
Why will it be different? Assume this is smooth. There is no friction.
Okay, then no reach the same height.
Yeah, so what is the reason why it will reach the same height?
No resistance present, sir.
Yeah, you can say energy conservation.
Okay.
What is the energy at the initial point?
Energy.
Yeah, and what about kinetic energy?
0.
Yeah, so finally also it will stop, right?
Okay.
There is no kinetic energy, so the height is different. It will be h1, but there is no dissipation. So both of these things should be equal. That means h1 is same as h. Okay. Now suppose if I reduce the angle of inclination of this plane, so will the height it reaches, will it change? Suppose this inclination angle, say theta. Suppose it decreases inclination, what about the height that will be attained here?
There will be more, sir.
Height will be same, but the distance traveled will be more. Suppose the inclined plane was like this. Okay, it will reach the same height. Because energy has to be conserved, no? But the distance it has to travel will be more. Okay. So suppose I reduce the inclination of the plane like this. So it will reach the same height, but the distance it has to travel is more. But suppose I make the inclination continuously decreasing and finally I make it flat. Okay, then this thing will not stop at all. It will keep on going because it is not able to climb that height. No, of course friction is not there. If friction is there, it will stop. There will be some dissipation. But suppose assume it's a ideal case where there is no friction. So this thing will keep on moving, right?
Yes, sir.
So this is a proof that right now when it's moving, there is no force on it. In the direction of motion, there is force on the vertical direction. Gravity will be the downwards. And what is the balancing force that is there in the upward direction?
So,
Weight is acting downwards, right? Because Earth is downwards. And what is the balancing force? Others will start flying, no? This is a normal reaction from the ground.
yes, sir.
This is a weight mg, but along the direction of motion, there is no force. Okay, so when the force is zero, this thing keeps on moving. So this is sort of a proof of, or the understanding of why there's no external force is not required for the body to be in uniform motion. Here the ball is moving with uniform motion along this horizontal direction with no force in the horizontal direction. Okay, so this experiment was done by whom?
Galileo.
Yeah, so this is important contribution, because intuitively you can say if something is moving, something is pushing it. Okay, but he was on who said if something is pushing, it means acceleration should be there, but velocity can remain constant without being pushed. But in reality, there will be some friction force. To overcome that friction force, we have to push it to keep it in uniform motion. Okay, so in reality, to keep in uniform motion, the net force should be zero. So there has to be an applied force which will balance this friction force. In reality, there will be some friction force in this direction. So you have to keep an applied force in this direction so that these two are equal for it to keep it moving in uniform motion. Okay, but without friction force, there is no need to apply an external force for it to keep it uniform motion. So this is the same thing, law of inertia. So Galileo's new insight, both body at rest and uniform linear motion are equivalent. Equivalent in the sense, both of them don't require an external force. Without external force, a body can be in rest or it can be in uniform linear motion. This is also important. Velocity is a vector. So even if the direction changes, it means that there is acceleration. Okay. So what is an example of a motion in which the velocity is not, magnitude of the velocity is uniform, but the direction is changing?
Circle, uniform circle.
Uniform circular motion, that's a horizontal circle. Okay, vertical circle, it will change.
Okay.
In vertical circle, the velocity will keep on changing. And also the magnitude of the velocity will change, and also the direction, both will change. Because when the vertical circular motion, the velocity will be maximum here, it will keep on decreasing and will become zero here. And after that, it will return. Like an example is a simple pendulum. The velocity is maximum here, it will keep on decreasing and become zero. So here the magnitude of the velocity is also decreasing. This is also a circular motion, but this is vertical circular motion. Okay, so in horizontal circular motion, what is an example of horizontal circular motion? Example of a horizontal circular motion is what? See, this is a pendulum, and this is a conical pendulum. You know what's a conical pendulum, right? So this thing moves in a horizontal circle, gravity is downwards. Okay, so this is a uniform in magnitude also. Our direction is changing, but the magnitude of this velocity is uniform. Is this clear?
Yes, sir.
And also, you can say object lying on a table and it's connected by a string. Okay, and on the horizontal table, this thing is moving. We give it a push and say this table is frictionless. So this thing will keep on moving and it's uniform in magnitude also. Direction is changing, but the magnitude is also uniform. Unit first law of motion is based on Galileo's law of inertia. So it says that when there is no external force, the body will keep in rest or uniform velocity. Basically, it means acceleration is zero and force is zero. Second law, you know, force is rate of change of momentum. And what is momentum? Momentum is a vector quantity, right? So it's mass into velocity. Okay, so momentum is also a vector, and rate of change of momentum is the force. From this you get m into a if under what condition?
Mass is constant.
Yeah. So what is an example of a mass which is changing?
In rocket,
Yeah. If you consider a rocket as a system, in the case of rocket, the fuel is burned, it's moving out, right? So if you consider just this rocket, this thing as your system, so the gas which is coming out, because of that, the mass of this thing is decreasing. Okay, so here for this rocket system, the change of momentum, the rate of change of momentum will be dp by dt, mv by dt, so there will be dm by dt into v plus m into dv by dt. And suppose if you consider the situation where the rocket is moving with a uniform speed, okay, so then the second term will go away. So only this d into dm by dt will be there. Okay. So the correct way of saying Newton's second law of motion is not F equal to ma. F equal to ma is true under the assumption that, under the condition that mass is constant. So the more general statement will be force is rate of change of momentum. Okay, and also it's a vector. Momentum is a vector, so rate of change of the momentum vector. And what do you understand by free body diagram? So this is an example of a mass on a surface. Okay, so this thing, free body diagram of this is this one. So what has happened when going from here to here? What have we done? We have just isolated the mass in contact with some surface. No, so the surface is being removed. So instead of that surface, whatever is the force acting on that, and also there is earth. So the surface is removed and also the earth is removed. So only mass m is considered and nothing of the universe is present. Earth is also there. So the effect of the earth has come here in this force. Okay, because earth will just attract this mass, right? So the effect of the earth is replaced by this force and the effect of the surface is the normal reaction, right? So that is the surface is being removed and we have put a normal reaction to produce the effect of the surface. Okay, so free body diagram is this body m is free here. Okay, it is not in contact with other things, but the effect of those contacts is being represented by the forces. Okay, so now this body is being acted upon by two forces and there is nothing else in the universe in contact with it. Is it clear?
Also,
yeah, this is very basic. Have you heard of this term, Lamest Theorem?
in particular.
Okay, so basically, when there are three forces, when will the three forces be in equilibrium? Suppose these three forces are acting on this point. Okay, so when will this point, say that this is a point mass, so when will this point mass be in equilibrium? You know what is an equilibrium? What is equilibrium mean?
That the effect is nullified, but the effect of
force is zero, right? F net is zero. And there is one more condition for, and it's a vector. Okay, and what is another condition for equilibrium? Can you figure out what is it? What is this tau n? F is force, right? What is tau? Torque. Yeah. In the case of rotational motion, for the thing to be in equilibrium, both should be zero. Okay. But in chapter, this is final Newton's laws of motion. So we are basically considering point masses. For point masses, there is no rotation because rotating point doesn't make sense. Only with the body has finite size. rotation will come into picture. Okay, for a point mass, even the block which you are considering connected to strings, we are assuming it's a point mass. Okay, so and when there's translation motion, the torque won't be there. That's also another reason. So here in this particular chapter, okay, so basically this point will be in equilibrium if all these forces are in balance, right? So the net force F1 plus F2 plus F3 should be how much?
0.
Yeah, see, to 0 to be in equilibrium. And for F1, F2 plus F3 to be 0, what is the condition geometrically or vectorially? In terms of geometry, it should form a closed figure. Yes? You know polygon law of addition of vectors, no? If there are 3 vectors whose sum is 0, then it will form a closed triangle. First vector, second vector, all should be continuously running. Okay, what are the conditions for 4 vectors to be in sum to be 0? And the 4 vectors should form a closed figure. It may not be rectangle, it can be any shape. Okay, but it should be closed.
Okay.
Similarly, inside a polygon, okay, if it forms a closed polygon, then the sum of forces is 0. Okay, if it suppose if it doesn't form a closed figure, okay, so what is the sum of these 4 vectors? See, this is the 4th vector, first vector, second vector, this is the 3rd vector. What is the sum of these 4 vectors? You have to take the tail of the first vector and join it with the head of the last vector. So this is the sum of 4 vectors. This polygon law of addition, no?
Yes, sir.
Okay, so when these two and this vector is touching this first vector, so then this vector which is joining the tail of the first vector and the head of the first vector is 0 vector. Right?
Yes, sir.
So that is why when these vectors form a closed polygon, the sum is 0. So since these 3 vectors, sum is 0, so it should form a closed triangle. Right? And also the length of the vector is proportional to the magnitude of its suppose if 5 newtons is 5 centimeters, it will be 6 newtons 6 centimeters, if it is 3 newtons, it will be 3 centimeters, right? So suppose I try to form a triangle of these vectors, say F1 is like this, so it should form a continuous triangle, right? So F2 is like this. Oh, no.
No, it's not continuous.
F1 is like this, so F2 should be this way, and F3 should be this way. I'm not drawing it properly, but the sense is correct. So this is F1, this is F2, this is F3. Okay, so this thing is forming closed triangle means for a triangle you have sine rule, right? A by sine A equal to B by sine B equal to C by sine C. You know this, no? Yeah, and so the length of this A is length of the side. So this is proportional to F1. This length of this side is proportional to F2. So this is proportional to F3. So F1 by sine alpha equal to F2 by sine beta equal to F3 by sine gamma. So it's basically sine rule, and the length of the side is basically proportional to the vector magnitude, right? So instead of E, we have F1 by sine alpha. So this is true if they are in equilibrium, because only when they are in equilibrium, they form a closed triangle. Only for a closed triangle, we can use sine rule, and this is basically sine rule of a triangle.
Okay, then.
And this is named after a person called Lamest. So when 3 forces are in equilibrium, we can say that this condition is satisfied. And sine alpha is opposite to F1. If you draw the forces like this, all the tails touching each other, so F1 is opposite to alpha. Alpha is the angle opposite to F1. And similar to F2, the opposite angle is beta. And F3, the opposite angle is gamma. Okay.
Yes, sir.
Okay. So find acceleration of both plots and tension in the string. So this is a very simple starting question. So this you already done, right? But already done. So so here there is a string. Pulleys are frictionless. Suppose M1 and M2 are same. So what is the acceleration? Suppose M1 and M2 are same. Okay. So what will be the acceleration in that case? Will it move? It do not move because both are equal, so 2 kg, 2 kg. If you say it will move this way, I can also say it will move this way because both are equal, no? By symmetry. So it will not move. But if it has got some initial velocity, it will keep moving like that, but the acceleration will be 0. Because it's equally pulling on both the sides. No? Both sides are 5 kg, 5 kg. So why will it move on one direction? Unless there is some initial velocity. Assume initial velocity is 0. Okay, but in general, the mass, whichever mass is heavier, suppose M2 is heavier, then it will move this way.
Okay.
Acceleration will be this way, and this guy will be upwards, and the acceleration will be same magnitude. And this, then we can write Newton's laws of motion, second law for this block. So this tension is moving downwards, right? So there's a net downward force. So M2G minus T will be equal to M2 into A. This equation you know, right?
Yes, sir, T equal to M2
Yes. Okay, similarly for M1, it will be upward force is net force is in the upper direction. So it will be T minus M1G equal to M1 into A. So if you add these two equations, T will cancel, right?
Yes, sir.
And you will get this one.
Yes, sir.
Okay, and the tension expression you can get by substituting this one. Okay, so the important thing to note is when M1 equal to M2, acceleration is 0.
Yes, sir.
That's as expected. Okay, so this is very basic thing. Here, find that, okay, this is a smooth table and the masses are different. If the masses were equal, we can say acceleration is 0. But since this 5 kg is heavier, so it will move in this direction. And this thing will move in this direction. But the magnitude of acceleration will be same. Both will be because it's the same string. Basically, the string will decide how far it's moving, right? And this is sorry, the strings are different. But if this string moves by 1 centimeter, this string will also move by 1 centimeter. Otherwise, it will be slacking. Okay, so all the strings are tight. Okay, so whatever this string moves, this string's move, this string is same. So if this thing moves up by A, this thing will come down by A. That is clear. No, both acceleration will be same. Okay, so this thing you can again write phi into G. So here the acceleration here will be different. It will be T1, say, and this acceleration is T2. You know why the acceleration tensions are different? Why these two tensions are different, T1 and T2? Because it's a different, it's a different string, no? Only when the string is same, the tension will be same. These two are different strings. Okay, and also this 2 kg is moving with an acceleration. So obviously there has to be a net force on this one. The net force on this in the direction of motion is T1 minus T2. Weight will be downwards and normal reaction will be upwards. So that is the normal reaction, normal direction. Okay, but the direction of motion, which is the horizontal one, there has to be a net force because this thing is moving with an acceleration in this direction. And this acceleration is same as this acceleration of the other two. Okay. So all three, 5 kg, 3 kg, and 2 kg will move the same acceleration magnitude. Okay, but the directions are different. And since this 2 kg is moving acceleration, obviously there has to be a disbalance between the forces T1 and T2. Okay, so this problem you know how to solve, right? There will be 3 variables, T1, T2, and A. So we need 3 equations. One equation you get from this 5 kg block, another equation you get from 3 kg block, and the third equation you get from 2 kg block. Okay, so you have to find, you have to eliminate T1 and T2. So you will get A from that. So this you know how to do, right? Yes? I don't know how to do that. Okay. Right. And there is a trick way of doing it. Okay. So do you want to know the trick or not?
Yes, sir.
I don't like tricks, but if you want, I can say. Okay. So this is equivalent to. So this thing you can consider equal to. So this 2 kg block is there, no 2 kg, and then there is a string. Okay. And then here we have 3 kg and then 5 kg block, and there is a force acting here. So I'm just straightening this whole system. Okay. So what is this force here? This force. It's weight of the 3 kg block, right? 3g. And here the force is 5g. Okay. So if I consider this whole thing as a system.
Sir,
Ah,
sir, can I get 5 minutes break, sir?
okay.
My father wants something, sir.
So this thing I can straighten out like this: 5 kg block, 2 kg block, 3 kg block, and the two strings. So I'll apply this force of 3g on the right side. On the left side, it's the force of 5g, which is equal to these two forces. Okay. Now I consider this whole block system as one system. So what is the total mass of this one? F plus 2 plus 3, so 10 kg. And the net force acting on this combination is 5g minus 3g towards left. Okay, so the net force is 2g. Okay, and the total mass is 10. So from this I can get the acceleration as 2 meter per second square. Okay. So to find the acceleration of this system, and the acceleration of all the blocks are same. So in that case, I can consider this an equivalent figure. And this equivalence is for calculating the acceleration. Okay. So is this clear?
Yes, sir. Then what is the trick to find the?
Speak loudly.
So what is the trick to find the tension, sir?
No, speak.
Anyway, we have to find that retracing argument, sir.
But suppose you want to find the tensions individually, then this trick won't work because you have to write the equations individually. Okay. So only for finding the acceleration, this equivalent method will work.
The T1 and 60 Newton, sir.
T1 is what?
60 Newton.
No. Okay. In this question, you just have to find the acceleration.
Okay.
Okay. So once you know the acceleration, then we have to write the equation for this one. T1 minus 3g equal to 3 into A. So T1 is 3 into A minus G. G is 2. So 2 minus 10 is minus 8. So T1 is the net force. T1 minus 3g equal to, okay. So T1 will become 3g plus 3a. So 3 into 12, 36 newtons. Okay. So if you have to find T1 and T2, then you have to write the equations individually. But you have to find the acceleration of the system, which is same for all the three blocks, then this equivalent circuit will work. Similarly for the first one also, to get the acceleration, you can straighten this wire out. So the net force acting will be m2g minus m1g, right?
Yes, sir.
Divided by the total mass.
Yes, sir.
That will give the acceleration. But to find the tension, you have to write the individual equations. Further, the trick will not be useful. Okay.
So, but I guess that T is 60 Newton, sir, right?
Which one? This one, T1.
T.
T,
T is 60 and
that's very simple, no? It's moving downwards, right? So it's 5g minus T equal to 5e. E. The tension will be 5g minus 5e. 5g minus 5e equal to 5e. 5e 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 minus 5e equal to 5 into G minus A. So this is 8. So 40. Is that clear?
So, but I use the formula T equal to 5 into A plus B.
5
Is
into?
that right?
No. That is for
A
this. 5 into A minus G.
A plus B.
No. That is for the block which is going up.
Yes, it's going down. So 5 into G plus A.
No.
T equal
No.
to.
Hold on. 5G minus T. This equation is correct, no?
Anyway, we'll get the same thing now. Yes, sir.
So tension of the block which is going down will be less. The tension of the block. No, that formula is correct for this one.
So for upper one, it will be T1 is equal to A minus 3G, sir. M into. For the second one, I'm asking, sir.
No. T equal to 40 newtons. Is this clear or not?
This one, okay, sir, but this is the usual method I use for this.
No. When you're using formulas, you have to understand when the formula is valid. Okay. So if you're not getting 40 newtons, the method is not correct. T equal to A plus G is 2 for this 3 kg block. For 3 kg block,
Sir, if it is equilibrium, then upward force equal to downward force only, no, sir.
no. It's not in equilibrium. It's moving with acceleration. No. Equilibrium is acceleration. Equilibrium is acceleration is 0. Okay. T1 minus 3G equal to 3A. So here T1 equal to 3 into A plus G. So the block which is going up, that tension force should be more because it is to balance this weight. No.
Yes, sir.
Here also it's balancing the weight, but MA is, you can replace the pseudo force downwards. No, or you can think like this, since it's accelerating upwards, this force should be dominant. Okay, and this thing is downwards, no? So weight should be dominant. So when weight is dominant, tension should be less.
Okay.
Okay, so if you're using a formula, then you have to understand that formula properly. You should know when it is valid, when it is not valid. Otherwise, you have to go to the basic.
Okay.
Okay, and this shortcut trick is valid only for finding the acceleration.
Yes, sir.
Okay, right. This one, the masses are in motion, reading of the spring balance. So the spring balance is just a spring, and the extension of the spring corresponds to what? The extension of the spring, what will it depend on? Suppose this spring has length has increased by x, so that will depend on the force with which this thing is being pulled, no?
Yes, sir.
Okay, so it's proportional to the force. So that force with which pull is the spring constant k into x. Okay, suppose if it is 5 Newton, if the extension is say 1 centimeter, if I pull with a force of 10 Newton, then the extension will be 2 centimeters. So as force increases, the extension will increase, and k is a constant, spring constant. So how will you solve this problem? You have to find the, so what is reading of the spring? What is the meaning of this one?
Which one, sir?
Reading of the spring means the spring will basically be the tension of the spring. And tension of the spring is same as the force which is pulling this thing down. We are applying some force to pull it, no? So because of that, there will be some tension here. So the spring reading is basically this tension force.
Okay.
So this way we have to find the tension force. So what is the tension here? So if you draw the free body diagram of this pulley, the downward force are the two tensions, no? And these two tensions are same. Why is it same?
Same string.
Same string, and also this pulley is smooth and also massless. Okay. And this is the force. And say T1. T1 should be equal to 2T because the pulley is in balance.
Okay.
Okay. If you want to be precise, actually, the pulley is accelerating downwards. Even if it's accelerating downwards, this force will be in balance because the net force is mass of the pulley into acceleration. And what is mass of the pulley? Is it clear? That is the assumption. That's the usual assumption, right? The pulleys are massless and frictionless. And the reason for giving massless is we can balance these two forces. So when the pulleys are massless, T1 equal to T2T. Otherwise, it will become complicated. Okay, so this is the reason for assuming the pulleys are massless. So once you find T, okay, you can find this F, which is 2T, which is pulling the string. So this will correspond to the spring reading, spring balance reading. Okay, and how do you find the tension here?
To M1 into by M1 plus M2.
Yeah. So from there we can find the tension as 4G. Okay. So the spring balance reading will correspond to twice the tension, that is 8G. So that is 18 Newton. Assuming G is 10, so this will correspond to 8 kg. Okay, so is it clear? Yes. The spring is that the tension force which is pulling the string is 80 Newton, no?
Yes, sir. 1 kg is equal to 10 Newton.
Yeah, if you assume G is 10.
Okay.
Okay, so under the assumption that G is 10, this will correspond to 8 kg. Okay, in the example it will be given clearly, G is 10.
Okay.
Even if you assume, don't assume G as 10, if you write in terms of G, it is 8G only. Okay, so 8G corresponds to 8 kg.
Okay.
Okay, so even for 9.8, it is valid. If you write in terms of G, it doesn't matter. Okay. Okay, this one, NEET 2013. So the masses move upward with constant speed V. What is the net force on the block of mass 2? So this is a very simple question, 2013. So you're understanding the question?
It's a constant speed.
Yeah, it's a constant velocity. What is the acceleration? Acceleration is 0. So an acceleration of 2m is also 0. All the things are moving with the same uniform speed. So all the accelerations are 0. So if you take a 2m, its acceleration is 0. So net force acting on 2m should be 0. Because acceleration is 0. So the correct option is option A. Is it clear? Okay.
Yes, sir.
Okay. So this one, the particle moving with velocity v is acted upon by 3 forces. shown by the vector of a triangle PQR. So P, Q are continuous vectors, and they are forming a closed figure, closed polygon. So the velocity of the particle will be, yeah, velocity will remain constant. Acceleration is 0 because the net force is 0. So because of that, velocity, he's asking velocity.
Constant.
Okay, is it clear?
Yes, sir.
Right. But suppose if this thing is not getting close, suppose this is open, okay, then it will move with some acceleration. Then the velocity will increase. Okay, but here the triangle is closed. Okay, suppose this PR was like this. Okay, and this guy is, so the head of the first vector and the tail of this one, so there is a difference. So the net force will be this much. Okay, so this net force will give an acceleration. So that means the velocity will increase. But here it's a closed triangle, so the net force is 0. Okay, you have to find the mass of E block for the thing to be in equilibrium. Okay, so equilibrium means acceleration is 0, so then net force is also 0. So the net force on acceleration of all the 3 blocks will be same. So the net force acting on all the 3 blocks should be 0. So how do you find the mass A now?
But I think that A is going down.
Yeah, you have to write the equation for A, equation for B, 2 kg. And so from this equation for A, you get the value of T1. From equation for this one, 2 kg, you get the value of T. And this 2 kg block on the plane, it is acted on by 2 forces, T and T1. And the weight component, weight is vertically downwards, this 2. That component will be downwards 1 and then normal component. You can forget the normal component, normal to the plane. So this weight component downwards will be mg sine theta. So basically this 2 kg block is coming under 3 forces, T, T1 and 2g sine theta. This this basic thing you know, right? If you have an inclined plane of angle theta, the force that is the weight component that is downwards is what?
Downwards.
Yeah, weight.
Yes,
mg sine theta.
Downwards, sir. Vertical direction that will be.
Not vertical downwards. The component along the plane, downwards along the plane. So it will be mg sine theta, right?
Yes, sir.
So mg sine theta is the weight component which is pulling it down, and mg cos theta will be giving the normal reaction. So T1 you can straight away write without any equation because it's in equilibrium. Since in equilibrium, these 2 forces are in balance. T1 is same as mg because acceleration is 0. Why is acceleration 0?
It is in equilibrium.
Yeah. So similarly, this T is 2g because this is also in equilibrium. Okay, so you know T and T1 and 2g sine theta. So from that you can, okay, these 3 should be in equilibrium. So T plus 2g sine theta should be equal to T1.
3 kg, sir.
Yeah, you got the answer?
Yes, sir.
Okay. So this is right. A player, this is also very basic, 2001. Player takes 0.1 second to catch the ball, move with velocity 20 meters per second. So the force imparted by the ball on the hand. So how will you do this problem? So what is the first starting step? Is this clear?
Okay, sir.
Okay, and what is delta P?
P del V. Sorry, M del V.
Mass into final. Sorry, this is initial. So the final is 0 minus initial divided by delta t. Delta t is how much? 0.1. So if you just take the magnitude is 150 by 1000 into 20 divided by 0.1. 0, 0, 0, 0, 10 and 0.1 will go. So it is 30. Is this clear? Done? Your mic is off.
Yes, sir.
Okay, so this is a better way of writing the equation here. Force is rate of change in momentum, and in the case of finite time interval, it can be written as delta v delta t. Okay, because he has given us 0.1 seconds, which is a finite time interval. So it's delta v delta t, and delta v, you know, right? So this is a better way of solving the problem. He has solved it in some other way, but this is a better way of solving the problem. Okay. Find the tension in the string between 2 kg and 3 kg. So this tension you have to find out. This is also very simple, right?
All actually are same only,
No, the tensions will be, this is a different string, right? The tension here will be different. The tension here will be T1. Okay, here we are just applying a force. There is no string here. So there are two strings with two different tensions. Okay, so here we can find the acceleration of the system using the trick. Okay, so we can consider this whole thing as one system. So to find the acceleration is net force by net mass. Okay, net force is towards right, that is 6 Newton. Okay, and the total mass is 6. So acceleration is 1 meter per second square. So to find the acceleration, you can use the trick. And once you know the acceleration, you can find this tension by writing the free body diagram of this 2 kg block. Because 2 into E should be equal to T minus 8. Done? Okay. This trick you can use for finding the acceleration. Because the acceleration of everything is same. So the acceleration system is also same. Okay. So the folding a considered system and the net force acting on the system is 14 minus 8. Divided the total mass of the system is whatever.
30 Newton.
Answer is 10. Tension is 10.
Tension on the first 1 kg.
Yeah. Between 2 kg and 3 kg.
10 only, sir.
Yeah. Okay. 2011 question. A person of mass 60 kg inside lift of mass this one presses the button on the control panel. The lift starts moving upwards. Okay. Acceleration is this one. G is 10. So tension on the supporting cable. This is also very basic. So the first thing you have to know the free body diagram of the lift and the person as a system. So what is the answer? Got the answer?
No, sir. $11,000.
Yeah. So the force, you have to consider this lift and with the man inside as a system. The force acting on the system is the tension upwards. Okay. And then the weight of the system, that is 60 plus 940. Okay. And the net, the whole thing is accelerating upwards with this one. Okay. Done now?
Yes, sir.
Okay. This one, 2003, a monkey of 20 kg is holding a vertical rope. The rope will not break when the mass of 25 kg is suspended from it, but it will break the mass exceeds 25 kg. A monkey of mass 20 is holding a vertical rope. Okay. The rope will not break with the mass suspended from. Okay. So this is the breaking strength of the rope, 25 kg weight. But if the mass is 25 kg, what is the maximum acceleration which the monkey can climb up around the rope? This is also a standard question. Suppose the monkey is just standing on the rope, it's not moving. So what will be the tension in the string?
20 G.
It is just balancing the weight. But when it's trying to move upwards, okay, the tension should increase so that T minus mg should give me ma. Okay, if A is 0 means tension will just be good weight. But here it should be tension. This mg plus something, right? So the tension will increase. And this maximum tension is how much? Without this 25 into G. 25 kg, but the force corresponding to that is 25 into G. So T maximum is 25 G. So the acceleration maximum is 25 G minus 20 G. Okay, so that is 5 G. 5 G divided by this M. So 5 G by 20. So it's 1/4 G. So it's 10 by 4, 2.5. Is it clear?
Yes, sir.
Suppose the monkey is going downwards. So what is the maximum acceleration with which it can go?
Going downwards.
Right now the monkey is going upwards, no? Suppose the monkey is going downwards, then what will be the maximum acceleration? So it's going downwards with the acceleration, say E1. It can be infinite. You don't have to think too much. It's going downward, so the net weight downwards is mg minus t equal to m into a1, right? So from this we can get okay, T max is maximum breaking strength. So this tension mg minus t equal to m into a1. So that is going downwards. So okay, the tension mg into g minus a1 is tension, right? Okay, so so this acceleration can okay, no. So the limit is the tension has to be positive quantity.
25 G.
Okay, so the minimum tension is 0. Okay, another way of putting this question, suppose the mass of this monkey is say 50 kg. So in the second case, let the mass of this monkey be 50 kg. So in that case, this tension, so this thing should be equal to 25 G. When it is 50 kg. So this in this case, this A1 should be
That is still climbing up on me.
8.5.
It's climbing up or climbing down.
Your voice is not clear.
The monkey is climbing up or down, sir?
Down, down. If it is climbing up, means it will break because it's 50 kg. Okay. When it's going up, it will be 50 kg plus additional weight. When it's going up, the tension is me to a plus g, no? Okay, mg plus me when it's going up. So mg itself is 50 g. So the tension will be more than 50 g if it is going up. So if it is going up, it will definitely break. But if it is coming down, means there is a chance of not breaking because the tension will be m into g minus a. Okay, and this m into g minus a should be equal to the maximum tension, that is 25 g. So this thing should be 0.5. So okay, A1 is 9.5.
E by 2. A1 equal to.
If you assume G as 10, then A1 is 9.5. So it's coming down with an acceleration 9.5, but the thing will not break. So if it is coming down with the acceleration,
Coming down means then the equation will be 50g minus 25g by 51 minutes. Right?
your voice is not clear.
mg minus 2 by m. If it is climbing down means.
Climbing down means the net force downwards is what? 50 to G minus A1, right? That should be equal to the maximum tension which I withstand. This is the limited case. In the limited case, the tension will be maximum. Okay, that should balance 50 G minus A1. So this thing should be 0.5. So 25 into G. No, I'm making a mistake. Yeah, my answer is wrong, but my step is, the equation is correct, but the calculation is wrong. So A1 is, okay, you can find A1 from here.
A1 equal to mg minus 2 by m1 dimension. That is 50g minus 25g by 50.
50G minus 25G is 25G.
And 25g by 50. A1.
25G by 50, right? So it's G by 2.
Yes. Yes, sir.
Okay, so if it is coming down with an acceleration of G by 2, it will not break. It's a limiting case. And if the acceleration greater than G by 2, then it will not break. If the acceleration is less than G by 2, it will break. So this acceleration, downward acceleration A1 should be greater than G by 2. Suppose the acceleration is G, then the tension in the string will be 0. From the same equation. Okay. So while going downwards, if the acceleration is more, it's better.
Yes, sir.
Okay, and tension in the string is becoming 0 when acceleration is G. So greater than G, the string will slack. Okay, let's not complicate things. So downwards means you have to do this calculation. So this will be your rope of length L and mass M hanging from a rigid support tension rope at a distance X. This is also a standard question. So this is a rope of, usually the strings are massless, but in the case of a rope which has got a mass, it's a uniform mass, so it will have a uniform mass per unit length. Okay, so at a particular distance S, what is the tension in the rope? So this you know how to solve, right? So shall I move to the next one, or you got it? Your mic is off.
Right, sir, I'm trying.
So you know how to solve this problem?
I solved it, but now I don't remember.
Okay, so basically you have to consider two systems. One is the upper part, another is the second part. So draw the Fibonacci diagram of both of them and solve it. It's actually simple. So the bottom part, if you take, what is the length of the bottom part? It's L minus H, no?
Yes, sir.
So the weight of this thing will be M by N, that is the linear density, into L minus X into G. So this is the weight of this one, and this is the tension force which is pulling upwards. Okay, so the tension is, the rope is stationary only, so these two forces are in balance. So tension force is, yeah, straight away you get the answer. This is the answer. So basically you can say at x equal to 0, that is at this point. Okay, so the tension will be maximum, and the tension will correspond to the full weight mg. Okay, at this bottommost point, the tension is corresponding to x equal to L, the tension will be 0. Because if you take a small element here, the force that is pulling it downwards is the weight which is downwards, and the weight that is downwards is 0. So the tension which is acting upwards is also 0. Okay, this is the last element. Okay, tension is because of something which is pulling it downwards. There is nothing below the last element. So the force that is pulling it down is 0. So the upward tension is also 0. But here, if you take the topmost element, the force that is pulling out is the full weight. Okay, so that will correspond to x equal to L. Sorry, x equal to 0. So the tension will be the full weight, m into g. Okay, so as x increases, the tension will keep on decreasing. So tension is maximum here, and the tension is 0 here, and the tension is decreasing linearly. Is it clear? And the middle,
Yes,
middle point, it will be half of mg. X equal to L by 2, will be mg by 2. This one, if the acceleration of m1 is e, then there are two blocks, m1 and m2. Okay, so then the acceleration of m2 will be. So here, whether the acceleration of m1 and m2 will be same or not? Here m1 is attached to this string, no? M2 is attached to a different string. This string is different. M2 is attached to this string. Okay, which is going around and going like this. And M1 is attached to a different string. This string.
Okay. The tension also will be different also.
Yeah. Tension you can draw by drawing if you got like this pulley. So this tension will be 2T if this is T. Okay, so this is valid if the pulley is massless. Okay, whatever the pulley is massless, m into a is 0. This pulley is accelerating. Okay, it's not stationary, but that m into a is 0 because m is 0. Got it?
I will do this problem.
This T and T will balance this 2T because mass of the pulley is 0. Otherwise, it will not be in balance.
Okay.
So what will be the acceleration of m2? It will be twice.
Minus m2.
Sine you can fix. Okay, that's not a problem. But just consider the magnitude.
The farthest also, can we do that trick?
Okay, so one way of doing this is.
But acceleration is different, so it won't work out.
No, these sort of questions you have done or not?
No.
See, I can. The length of the string. Just a minute. The length of the string from the top point to the. Suppose I call this length of the string as L1 and this length of the string as L2 and the length of this part of the string as L3. Okay, and you can say L1 plus L2 plus L3 is constant, right? Because length of the string is constant. Okay, so actually the better way of doing this is I'll fix my coordinate like this and I'll measure say x from here. So this is the origin of x-axis and measuring x from here. And the coordinate of this point, that will be x1, and that is same as coordinate of m1 plus some constant. This is the constant length part. Okay, so whatever is the coordinate of m1, okay, let me call the coordinate of this m1 as x1. Okay, and the coordinate of this mass m2 as x2. This thing from here is x2. So x2. So the length of the string in terms of x1 and x2 is what? So the length of the string is x1, 2x1 plus x2 is the length of the string. Is that clear? Actually, the string is from here to here, plus a constant length. No. So actually, if you want to be more precise, you can say plus some constant. Okay, this constant. So the length of the string is this one. So that is x1 minus this constant, right? Constant length. And also, again, this x1 minus this constant length. Okay.
Yes, sir.
And this part is x2 minus this constant length. So 2x1 plus x2 plus some constant equal to x. Constant does not matter because it doesn't. So now if I differentiate with respect to time, twice I'll get 2x1 dot plus x2 double dot. Length of the string is constant 0, and 2x1 dot is 2a1 plus 2a2. Sorry, 2 is not required. Plus a2 equal to 0.
Sir, what is that one, sir? 2x1 dot.
How do you do? Dot is dx by dt.
That is velocity only, no, sir.
Yeah, but you differentiate twice.
Okay, okay.
Because we need acceleration relation, no?
Okay.
So this thing is equal to 0. So from this we get a1 as minus a2 by 2. And minus sign is also making sense because if a2 is positive means a1 is opposite, no? Downwards. a2 is upwards. So the directions are opposite. So that we have to find m2, no? So we have to find a2. So a2 is 2a1. And a1 is a plus beta 3. Is this clear?
Yes, sir.
Okay, and there is a trick way of doing this one. So the trick is tension dot A is 0. Because tension is an internal force. When you have a system of rigid body, a system of particles, the work done by the internal force is 0. That you are studying in chapter 7, rotational motion. When you have system of when you have a system, the internal forces which act, and this tension force are internal. T1 is internal force, right? If you consider the whole thing as a system, T1 is internal. The external forces are the weight mg. Okay, so the tension is an internal force. So the summation of T dot A is 0. So T1 dot A1 plus T2 dot A2 is 0, and T1 and A1 they are in the same direction. No, they are in the opposite direction because tension is always pulling is upwards, and this thing M1 is going downwards, so minus sign, and the tension is 2T. Okay, and similarly, T and A2 are in the same direction because tension is pulling upwards and acceleration is upwards. And
So, on what basis you are saying that M1 is going downwards and they didn't mention the M2?
no,
M1 is
we can assume one thing and be consistent with that. The assumption, okay, here the assumption is valid if M1 is much larger compared to M2. Okay, just make assumption at one step, and other step it should be consistent with that. So the assumption is this thing is going downwards. If my assumption is wrong, then I'll get negative sign, so I have to reverse the assumption. Okay. This is a standard way of doing it. Since this M1 is going down, then the M1 should be much larger compared to M2. Okay, shall we move to the next one? Okay. So this also you have a system of okay, 2 blocks and 2 pulleys. So but there is a single string. The single string tension is same if the mass of the pulley is 0 and also the pulleys are frictionless. Only under the assumption the tension will be same across the pulley. Okay, others will be different. So, so here also you can use this trick. That the trick is tension dot acceleration is 0, and also tension velocity is also 0. And also tension dot displacement is also 0. So T dot TA dot XA plus TB dot XB is also 0. Actually, there is the starting equation. From that, if you differentiate once, you will get this tension dot velocity as 0. And if you differentiate the second time, you'll get tension dot acceleration as 0. So you can use this trick. So if you assume the tension is, obviously the tension is constant throughout because it's the same string, and the pulleys are frictionless and massless. So the tension force acting on this block A is 2T, right?
Yes, sir.
And on block B is 3T. So here there is a T, and this tension will be 2T. So total is 3T. Okay.
Sir,
Thank you.
once again, 3T.
The total tension force acting on block is 3T. 1T is coming from here, and 2T from here.
Okay.
Tension in the string is T, but this part of the pulley with the tension will be 2T. And we are assuming, okay, he himself has given the direction as moving right. So since it's moving right, this tension will be towards left because tension will try to resist this motion. But for block A, the tension will pull this block.
Yes, sir.
So is it clear?
Yes, sir.
So you have to use this trick. Otherwise, another way of doing is to have the coordinates of A and B. So to have the coordinate, you have to take a stationary point because the coordinate has to be fixed. So if we take this as my, both the blocks are moving. So suppose I take this as my origin of x-axis and measure x from here. Okay, so this is my x-axis coordinate. So this coordinate of this xa, and this coordinate of this thing is xb. So the length of the string is here one xa is there, here another xa is there, and xb is 1, 2 xb, and one more xb is here. So length of the string is 2 xa plus 3 xb. Is this clear? Your mic is off.
How did you write that 2 and 3?
See, this is the coordinate of my x-axis at the point where it is fixed. Okay, so from here the coordinate of A block is xa, and the coordinate of B block is xb. So the length of the string is this part, no? So this length is xa, this length is xb, plus some constant. Constant length you can forget it because some constant I can add here, and when I differentiate the constant will go away. So this length is xa plus some constant. Okay, this is the same length, and here we have 3 lengths corresponding to xb. One length here, one length here, and one length here. So the total length of the string is 2xa plus 3xb equal to 8, plus some constant will be there. That constant is because of this length part and this length part, okay, and this length and that. So constant length you can forget. Now if we differentiate this thing twice, I'll get, I just have to differentiate, once because velocity, no? So 2va plus 3vb equal to 0. That is the same relation. Sign you can fix later.
Okay.
Okay, and since the block B is moving towards right, okay, so this thing will also move towards right because this thing will start pulling. So this thing will go like this. So the whole thing is going this way. So the block has to move towards right. Okay, this one. So these sort of motions are called constraint motion. What is the constraint here? Constraint mean what? Something is forcing you to behave in a certain way. That is a constraint. Okay. So what is the constraint here in this problem? The constraint is the length of the string is constant. Right? Then that is the constraint. And that constraint is giving the relation between VA and VB. Is this clear? Here also, the length of the string is constant. That is the constraint. Okay, and that constraint is giving the relation between A1 and A2. So similarly here, find the relation between V1 and V2. So here the string, same string, pulley is massless and smooth. So the tension here will be same. So this thing is being pulled with the velocity V1 towards right. So what is the velocity of V2? Okay. So how will you solve this problem? You can solve by this trick. Okay. T dot V is T dot A is 0, and also summation of T dot V is 0. So this is T dot P equal to 0. And this is V1 means the component of velocity is V1 cos theta plus TV2, because T and V2 are in the same direction. So P2 equal to V1 cos theta. And you can also solve by the length of the strings. And for length of the string, I have to take a fixed point for the origin. So I'll take this as my origin of x-axis. So the coordinate of this thing is this much is x2. And okay, so I'll measure. Okay, and the coordinate of the x coordinate of this point, okay, is x1, and the y coordinate is not changing, right? So just the x coordinate is, sorry, x is along this direction only. So this much is x1. And x1 is constant, it's not going to change. So but this length of the string is, this is theta. So this will be 90 minus theta. So the length of the string is x1 by cos theta. So x1 by cos theta plus x2 equal to the length of the string, which is constant. So if I differentiate this one, I'll get v1 by cos theta plus v2 equal to 0. So I have to find v2, right? I made some mistake here. x1. So this x1 by this coordinate of this one. So this thing is x1 by, sorry, this is complementary angle, no? So it's x1 by sine theta. This is sine. Sorry, theta is also a function of time. Theta is going to change with time.
Yes, sir. Half 90 minus theta.
So this thing is sine theta. So this length I can write as, so this is the constant height, the height of the pulley from the ground. That's not going to change. Let me call it h. Okay. So there is the length of the string is h square plus, okay, let me call this coordinate y1, h1 square plus y1 square, that is equal to the length of the string and length of this part of the string.
X1 sin theta.
No, x1 is not required. X1 is not going to change. So you can just forget x1. Length of this part of the string. L1 square. Okay, so L1 will be square root of h square plus y1 square plus this length is x2 equal to, sorry, equal to the length of the string. So if I differentiate this thing, I'll get the relation. So differentiating this means 1 by 2 root into 2y1 dot plus x2 dot equal to 0, and y1 divided by square root of this one is y1 is this one, so this is cos theta. So x2 is y1 cos theta, x2 is y1, so x2 dot. So v2 is v1 cos theta. So this y1 dot is v1, right? x2 dot is v2. Is that clear? Your mic is off. Okay. So since theta is varying with time, instead of writing this length of the string in terms of x1 and theta, you can write in terms of h. H is constant. Okay, and this is the coordinate which is changing, and that this coordinate we are interested, because y1 dot is the velocity of 1 and x2 dot is the velocity of m2. Okay, so you have to relate x2 dot and y1 dot, because x2 is vertical motion and y1 is horizontal motion. So the length of the string in terms of x2 and y1 we have to write. So that we are written like this, and once you differentiate this one, I have to write y1 divided by square root of this one as cos theta. So you'll get this one. Otherwise, you have to use this trick. Summation of t dot v is 0. So we'll close now. So your laptop is so laptop, what is the situation now?
This week can be
Okay. Because if you have these notes, then you can revise.
Yes, sir.
Otherwise, you have to. It's important to revise what you have done also. Right. So tomorrow we'll meet at 3:30.
Okay, sir.
And this coming Sunday we'll have the extra class.
Okay, sir.
Because I forgot yesterday.
Okay.
Okay, then bye.
Bye, sir.